Good afternoon. Thank you for joining us. The Raspberry Pi family keeps on breaking new ground, with the machine now used in everything from retro emulators to industrial projects and even space missions. We're now a year on from the launch of the Raspberry Pi 4. So what's next? I'm Carly Page, news editor of ITPro, and in this Q&A session, I'm joined by Raspberry Pi founder Eben Upton to find out. Hi, Eben. Thank you so much for joining us today.
Good to be here.
So to begin with, it's been almost a year since you released the Raspberry Pi 4 and almost a decade since the first Raspberry Pi was launched. So I guess how much has the Raspberry Pi changed in that time?
Wow. As you say, it's a year and a day. It's a year and a day now since
Year and a day.
Yeah, and we almost let yesterday slip past, actually. We got to kind of the end of the afternoon and suddenly realized that we've not said anything on social about it. Yeah, I mean, it's been a strange journey. You know, we've always, even back in 2011 when we first started talking about Raspberry Pi, we thought of ourselves, we described ourselves as a PC company, we measured ourselves against PC companies. And I guess what you've seen over the Raspberry Pi 1, 2, 3, 3 plus 4 kind of evolution is you've seen us that becoming, I guess, a plausible proposition for a larger and larger and larger fraction of the people who use a PC. We put on about, you've got to pick your benchmark, pick your metric, but we put on about 40 times the processing power in a Raspberry Pi 4 that we had in a Raspberry Pi 1 back in 2012. The $35 product, which is, I guess, $35 is still our signature price, although there are now more expensive Raspberry Pi 4s. We still really, really care about the $35 point because that's what we see children, who I guess were our original market, buying. That device now has 8 times as much memory. We've gone from a quarter of a gigabyte of RAM to 2 gigabytes of RAM. So there's been this kind of expansion in the capability of the device, and along with that has come an expansion in the range of applications, and obviously an expansion in the proportion of the PC market that we can address with the product.
Amazing. I guess with all these huge leaps in power as well, the Raspberry Pi has arguably helped to pioneer the modern use of ARM as a viable platform for end user computing. How do you feel about the adoption of this platform by companies such as Microsoft and this week Apple?
It's been a good building desktop computers on the ARM architecture, hasn't it? Yeah, it's something we've always believed in very strongly. You know, we're a British company. The machine of I had a BBC Micro when I was a child. That was the machine I learned to program on. I spent my childhood wishing that I could afford an Acorn Archimedes, which was, of course, the original ARM desktop computer, and never being able to. So there's still, when we had our first prototypes in 2011, some of the first people I got in touch with were RISC-OS Open, who maintained the modern port of RISC-OS. So yeah, that kind of building ARM desktop computers, I'd still get a kick out of the fact that we are the largest distributor of RISC-OS compatible hardware in the world. It's been a long time coming, and just I guess this week's announcements are just the latest. Maybe I guess the AWS, the Graviton announcements as well. They're kind of just the latest development in a cycle that started with these machines, the Acorn Archimedes, back in the late 1980s.
Absolutely. I guess with the current situation, have you had any challenges in building the Raspberry Pi 4 in the production process? Has that affected you at all?
It's been interesting trying to run a scaled computer manufacturer in a period when different bits. We build Raspberry Pis in the UK, so to some extent, I guess we weren't so affected by the early part of the year, kind of January and February, when things were difficult in China. We weren't as affected as other people. Where we did start to see, I guess we started to see challenges in March, coming into April. Where we had a combination of supply chain issues from China. We launched the 8 gigabyte Raspberry Pi about a month ago, and that had been intended to be an 8th birthday. We cut the price of the 2 gig product from $45 to $35 on the birthday, but that was really only half an announcement. It was supposed to be the full, both bringing the 2 down and then bringing the 8 gigabyte in as a new top end range. And we just weren't able to do that because there was an inductor. I mean, it was one of those ones. a challenge we've had all the time we've been doing Raspberry Pi is that you can have, there are something like 350 components on the Raspberry Pi, about 100 distinct line items in the bill of materials. And you can have 99% of those. And if you don't have the one, you can do nothing. And that's where we found ourselves with 8 gig that we were missing an inductor. And so we couldn't build the power supply. And so we couldn't launch the product. So that was a problem. We did also see some challenges, obviously, as the kind of COVID situation deteriorated in the UK. We had our eye on our manufacturing base in the UK. Actually, in practice, that was all very smoothly. That was very smoothly managed, smoothly and safely managed. I guess we benefited from a lot of automation. If you're building a product like Raspberry Pi in the UK, the way that you make it economical to do that is to have a lot of automation. If you have a lot of automation, then the number of people per square meter in the factory is low anyway, and the likelihood that you can get, you're much more likely to be able to. I read an article a week or so ago talking about the difference between 1 meter and 2 meters as a separation for COVID safety, and how that would allow production lines to go from 20% capacity to 70% capacity. And I'm thinking at 2 meters, we can do 100. We can do 100% capacity because there's so many robots. So that was okay. That bit was smooth, but it was the supply chain side. It caught us on 8 gig, and it also caught us on the high quality camera. We launched a 12 megapixel high quality camera in April. That probably would have been a month's hit on that. Actually, on lens, that one turned out to be lens supply. We had the cameras. Again, they're made in South Wales, but we weren't able to. We wanted to source cost-effective C and CS mount lenses from the Far East, and those then ended up being delayed because of COVID. But we kind of through it now, but it's been a learning experience. I think we were also lucky. We went into it on the Raspberry Pi 4 side with a reasonable stock position, so we had strategic stockpiles both in the finished product and also a lot of our components. So we probably could have sustained a 2 or 3 month complete collapse of the supply chain before we ran out of finished goods.
Great. Well, I'm glad to hear things are starting to get back to normal, because obviously the Raspberry Pi 4 is a hugely popular device, especially among hobbyists. Have you seen it also become popular for business users?
Yeah, absolutely. I mean, that's the other. So that was we dealt with the supply side of living through this COVID situation. The demand side has been very, very interesting, because we've seen both an uptick on the hobbyist community. I think you had some people who probably last year had deferred their purchases of Raspberry Pi 4 while they waited for the software to stabilize. There's a big software change from Raspberry Pi 3 to Raspberry Pi 4, meant that things like RetroPie, some of the emulators didn't come across straight away. So you have people who were waiting for that, and for whom being stuck at home in lockdown was an excuse to do that. But you also saw people, individuals and also corporates, actually saw some NHS as well, deploying them as, we have a very long-standing relationship with Citrix. It's the lowest cost and one of the highest quality thin client, Citrix thin client platforms. And so what we saw was a lot of people, as a lovely case of an NHS trust, had to move all of their non-clinical staff home over the course of a week or two. Suddenly, I mean, we've all seen this, how hard it is to buy a laptop. Suddenly they're casting around, what can we send people home with and have a remote desktop solution. So that happened to us. So we saw, March was actually our second largest month ever. So last September was our biggest selling month, at about 660K in the month, about 640 in March. And you can see all of our graphs kind of track, download, sales. They all track with a little increment. They all track last year's numbers up until about the 10th of March. And then you see that this year's numbers just decouple upwards, whether that's our Debian repository, download statistics from the Debian repository, number of people reading our magazines online, number of people buying the product. They all just see a very, very sudden decoupling as people in the West start to realize this is going to be serious.
And I guess another area where the Raspberry Pi is especially popular is among children, who at the moment are all having to stay at home. And, well, some are going back, but a lot of children are still staying at home. And I guess it's kind of the perfect time for them to embark on some Raspberry Pi projects. Have you noticed that over the past couple of months?
Yeah, we've noticed another statistic we have. We obviously have a lot of the foundation, so our parent organisation. Creates large numbers of educational resources. It has collaboration with FutureLearn to deliver online course content. All of those suddenly became busier. Children, parents, teachers, all of a sudden there was a sense that more people were getting involved. What's interesting to us is that kind of balance between. There's always been a split between, I guess, computing education and computing for education. We've seen ourselves, Raspberry Pi is it's traditionally been a computing education organisation. We exist to educate people about computers. But there's also computing for education. And the BBC Micro is a really interesting example of this. While it was a platform for me as a child for computing education, it was actually deployed as an education computer. So what were the BBC Micros used for in my school when I wasn't hacking on them? They were used to run French teaching applications and English teaching applications. And the thing that's really happened to us this year, partly because Raspberry Pi 4 was the first really PC equivalent product we've made, and partly because of the COVID situation, is that you're suddenly seeing people go, hang on, I need a PC to get on Teams or Google Hangouts or Zoom. I need a PC so that I can be educated, not so I can be educated in computers, but so I can be educated in English or French or whatever. And that's been the big change for us. We've done some work ourselves, some charitable work in getting, we had some extremely generous philanthropic funding to get units into the hands of children, but we've been getting them into the hands of children as general purpose computers. And that's super exciting for us, right? As a company that thinks of itself as a PC company, the sign that people are treating you like a generic PC is very, very, it's been a good year for us actually in that respect. That happened last year, we wouldn't have been ready to help out. And so we're lucky that Raspberry Pi 4 arrived when it did.
Absolutely. And is this something you also use at Raspberry Pi internally? Do you make use of the Raspberry Pi 4?
Yeah, we have a real dog food culture. Now we resisted the dog food culture for a long time, right? I'm not talking to you on a Raspberry Pi at the moment because it's not appropriate for this platform. But increasingly, we've never done dog fooding for its own sake. But increasingly, what we found is particularly, there are a small number of people in the organisation who still need Windows. But increasingly larger numbers of people, either because they're using technical tools which are better supported on Linux, or because they are using primarily a browser-based workspace. We're finding them using Raspberry Pi 4 a lot more this year.
Amazing. And I guess on a more personal note, what are some of your own projects that you've used the Raspberry Pi for?
Well, I use mine as a PC. I do use mine as a PC. So I have one in front of my I'm at home at the moment. I have one in front of my television as a PC, just a PC and media streaming box. Done a bit of robotics. Haven't done as much home automation as I'd like. We have a few places that I am still hoping to put Raspberry Pis to do automation stuff. The biggest use for me for Raspberry Pi is they hang off the back of my various iterations of Raspberry Pi, hang off the back of my home router. So kind of there's a feeling where when most people spin up, I need a VM, spin up a VirtualBox, a VM in VirtualBox, I go and get bare metal hardware. And so I have, a Raspberry Pi 1, everything from a Raspberry Pi 1 through to an 8 gig Raspberry Pi 4, hanging kind of off precariously, generally uncased. So with things between them to stop them shorting on each other, and then a big mess of USB power supplies, because power of Ethernet is only a fairly recent thing for us. And it's just, it all works and nobody breathes, seems to be it's kind of the motto. Nobody breathe on it all. Two pieces of metal will come together and then I will lose a pair of VMs at a time as two Raspberry Pis knock against it.
Amazing. And is there anything you've got planned that you'd like to do or that you'd like to see somebody else do? Is there one project you've been hoping for that hasn't yet happened?
I'd love to get outside low Earth orbit. We've had Raspberry Pis on the International Space Station for about 5 years now. Well, we've had two on the International Space Station, so that's the AstroPi program that allows young people to write code and run it in space. The fun thing with the ISS, of course, is lots of other people who want to run experiments on the ISS end up using Raspberry Pis to compute for that. So at any given point, the ISS has got, maybe up to 10 Raspberry Pis on it. We don't know about them usually until they come down. People send us a picture. They don't tend to get returned on the Dragon when they bring cargo down on the Dragon. So I'd love to get outside low Earth orbit, love to get something on the Moon, love to get something in deep space, love to get something on Mars. Did mail Elon a few years ago when they were talking about doing Red Dragon, and they were talking about trying to put a dragon on Mars. So look, if you can give me 15 grams, give me 15 grams, and 100 board link, and we'll give you, your code in space has been an amazing, as a way of motivating kids. Your code in space has been amazing. We've done tens of thousands of programs run on the ISS. I figured your code on Mars would be fantastic. Didn't hear back, sadly. But I would love to do that. For us, really, a lot of it's about software. We're between generations. Raspberry Pi 4 is going to be a long generation for us. It's our first 28 nanometer platform, so we've got a lot to sweat out the platform. The way we sweat performance out the platform is by doing software work. If maybe half the gain in performance that you saw on Raspberry Pi 1 through Raspberry Pi 3 was actually software optimization, not hardware improvement. So we'll be doing that to Raspberry Pi 4. Trying to close the remaining gaps to PC. How do you go on Netflix? How do you officially get on Netflix? Of course, you can get on Netflix on the Raspberry Pi. But how do you officially get on Netflix on the Raspberry Pi? How do you do all the video conference? I mean, that's been a learning experience for us. What do we have to do to persuade Zoom and Teams and everything else? What do we have to do generally in the way of user agent strings, carefully crafted user agent strings, to convince all of these conferencing platforms that we can run them, because we can, but sometimes you have to maybe be a little discontinuous about what browser you are in order to persuade them to serve you a version you can run. So there's a lot of that. It's just attention to detail work, really. I've got to transition to 64-bit. That's the other thing that, along with the 8 gig, when we launched the 8 gig product, you can make use of all of that memory. You can make use of all that memory in the 32-bit kernel, but you can't have one process with more than 3 gig mapped. So going to 64 bits in the future, we're also using that as an opportunity to, I guess a criticism of Raspberry Pi over the years has been that there's a lot of closed source elements to the board support. There's a large binary firmware object that manages lots of the internals of the system. Really using the transition to 64-bit as an opportunity to kind of clean house, get away from that. There'll still be a few things on Raspberry Pi 4, largely camera and legacy video stuff managed inside that world, but literally everything else on the platform then will be open source, will be upstream open source code. It's exciting.
It is. I'm just going to have to go back to the space stuff for a minute because it's fascinating. But it's amazing that your devices are out there. Could you tell us a little bit more about your code in space?
Yeah. So this is a thing that had its origins in a. I have a friend who works at did an MBA at a business school in Cambridge. I have a friend who is responsible for marketing that, and her brother I think he's an EADS employee. And about 18 months before Tim Peake went up to the station, I got a call, an introduction to Rick, saying, hey, we should do something. You've got an educational platform. We've got, obviously, Tim's trip to the station was seen very much, was conceptualized by the government when they funded it as being an opportunity to get young people excited about STEM. And there was this sort of feeling that we should do something together. Got the payload together in record time. Jonathan Bell in my team kind of worked all day and night for a year. Got not just the payload, of course, but the paperwork. They always say when the paperwork weighs more than the payload, then it's time to fly. And the payload itself was 2 Raspberry Pis, 2 $35 computers, each in a $3,000 machined aluminium flight case. They went up to the station. And there was always that feeling, when we started doing Raspberry Pi, there was always this, the idea was to rekindle young people's excitement about computers. When I was a kid, I was excited about two things. I was excited about space and I was excited about computers in the 80s. There was always that feeling that perhaps that was of its time. Perhaps it was like being, excited about motor, understanding how your car works in detail. Which said my father's generation, my grandfather could drive a car. My father could take a car apart and put it back together again. I can drive a car. And so maybe there's a one generation peak for technology when people are excited. And that was always the kind of the counter argument, why might Raspberry Pi fail in our mission among children, was that perhaps that was just the 80s for that time. And perhaps the 80s was that time for space as well, or the 60s through the 80s. What we discovered obviously with Raspberry Pi is kids love computers, and kids love, as much as anything else, they love the secret knowledge of being able to do a thing. Actually, the fact their parents aren't into it is so super important. Don't understand about it, super important. Kids love nothing more than secret knowledge and power over their parents. So that was a thing. And it turned out the space thing was as well. So we ran a program originally required astronaut time, required some of Tim's time per experiment. So we were very limited in terms of the number of programs. We now have two different programs. We have a more detailed program which does still require per experiment astronaut time. We also have a thing called Mission Zero. I think we have Mission Space Lab and Mission Zero. Mission Zero is completely unattended. So the Astro Pi units are now on the station LAN, so they can be, for a long time, they were isolated, they were air-gapped. Now they're on the station LAN. You can run programs on them. Mission Control can run programs on them without requiring an astronaut to physically insert things into the device, and so you can get a lot more throughput there. And Mission Zero just churns through thousands of kids' experiments, and there's some really fantastic ones. We've got cameras. We've got two units, one with the traditional camera and one with the infrared sensitive camera. And so you've got people pointing these out of the cupola and looking down on the Earth and trying to do plant health. Was one that we kind of thought people might do this, and we were excited to see it. Looking down on forests from space in a broader spectrum, but slightly more than optical spectrum, and then trying to make decisions, trying to estimate how healthy a forest was. You fly over California in the drought, and you see the trees look different. So there's these wonderful, still things that we did have one entrant. We do screen the code, although we do. It's fairly automated. We do screen the code. There's a manual code screening step, and we saw one piece of code someone had uploaded, which was had a bunch of network calls in it. And it turned out what it was trying to do was to find a globally routable IP address for testing the hypothesis that the Astro Pi units are globally routable, and trying to recover that and phone home to report that so they could then get to the unit on the ground. Of course, it is still air gaps. It's just because it's not air gaps right up against it, it's air gaps somewhere else. But it was a really nice try. I think the kid got a nice try from this.
Amazing. I think another really interesting use case I've seen with the Raspberry Pi recently is the way it's helping in this current coronavirus situation. I've seen that they're being used in ventilators even. Could you tell us a little bit more about that?
Oh, yeah, ventilators was, we're not in any of the UK programs, but ventilators obviously was a thing when that whole idea that people were going to try and have crash programs to build ventilators. That was something that we did get involved in. We've shipped over 20,000 Raspberry Pis into ventilators. We have several ventilator customers. So that's been amazing. That was a surprise to us. And it's one of those things where, a little bit like we found that we have supply chain challenges when we're trying to operate in this environment. Obviously, someone who's trying to build a lot of ventilators will end up having all sorts of supply chain challenges. So if you can take away the logic board inside the device as a challenge, because the Raspberry Pi is a very configurable logic board. One software on it, waggle pins. What you might build in a perfect scenario, you might build in dedicated logic or with an FPGA or with a microcontroller. In extremis, you can get the same functions. You may have to think a little bit harder about validating the software, but you can get the same function out of a Raspberry Pi. So that happened. That was interesting. We did do a little bit we used our PPE sourcing a little bit as well. So we have a lot of component sourcing capability in China. We did a little bit we started bringing PPE in for our own employees, and then gradually expanded that to, there are lots of bits of the peripheral health service that at least for a period at the start of the crisis were starved. That the kind of drawbridge came up, the kind of core NHS pulled the drawbridge up, and there were lots of bits of, peripheral health service, the ambulance service, for example. You wouldn't think that was peripheral, But so you end up in a situation where you have, if you've got a bunch of boxes of masks, and there's a bunch of people who've got to choose between going out to pick someone up with a mask or not, and they know you've got some masks, the phone starts ringing. So we did a little bit of that. That was probably even more surprising. I guess that was even more surprising to us than the ventilator thing. It probably took us further outside our comfort zone than
yeah.
The logic was.
Amazing. And looking a bit at the future of Raspberry Pi, so each time you release a new model, you seem to sort of hit the ceiling of what can be done with a device of this form factor. How do you keep pushing past that?
Well, we started from an interesting point, right? So we started from a point where we had an enormous amount of multimedia performance, relatively modest CPU performance. So we were on 40 nanometers, and we actually did an incredibly small fraction of the die area of the chip that was devoted to being a to CPU. So it's about 2.5% of the die area of the chip, the CPU. You look at a traditional AP, or you look at one of our modern chips, and you can see the ARM from space, right? But this little ARM was just kind of snugged in the corner of the chip. So for a little while, we were delivering performance increases by kind of moving the partitioning of the die back towards a more traditional partition, and you end up with Raspberry Pi 3 and 3 Plus with the A53 cores. You end up in a situation where you have about a third of the die. So you've got up towards 15 square mil out of a 40, 45 square mil die is ARM core. So that worked. But of course, what you find there is you start to run out of, primarily you start out of thermal capability, actually, because you can always keep adding transistors and making your die bigger, and you can always go and pick the A53 is a great core, but it's an in-order core. It's a little, in ARM's terminology, it's a little core. And so you can go and get a bigger core, but of course, can you afford thermally to toggle the transistors that you put down on the die? And we were kind of there at a variety of limits in 3 and 3 Plus. 3 Plus is still one of the products I'm proudest of, because it squeezes the same die, and it's fundamentally broadly the same die as 3, but has better packaging technology. So it has a kind of an advanced packaging technology that let us squeeze another 15, 16% performance increase. But it's kind of part of the Raspberry Pi philosophy. It's like we won't leave 15% on the table ever in any dimension. So we did that, and we took 40 nanometers to the end of the road. Very lucky to get a 28 nanometer SoC, 2711, which we use in Raspberry Pi 4. So that's taken us to a new process node. That probably lets us play some of the same games that we've been playing for the last few, that we played for the first 7 years of the program. We can play some of those games for a little while, I would hope. It's going to take, I think Raspberry Pi 4 is probably about a third of the way through the life of Raspberry Pi 4. I don't think there'll be a Raspberry Pi. There won't be a Raspberry Pi 5 next year. You're in a, going to a new process node is great, right? Because it's like the stairs, right? You can do so much. We always talk about the process, the chip improvements, and particularly the process improvements, as being like the treads of some stairs. And then we talk about the software work we do in between big steps as being like pouring sand onto the stairs, and it just softens the tread. And that's really where we are at the moment. So we're in a place where we've reset the clock a little bit by going to 28, and then we're going to play a lot of the software tricks that we played on 40 to get more performance out of the platform. And that's exciting. We have a compute module coming up. So as you know, we make a modular. One of the things that's been very surprising to us about Raspberry Pi is that people integrate them into products. So we have a line of SODIMM form factor, little card versions of Raspberry Pi that you can integrate into a product. There's a modular version of that. We've talked about this in the past. There will be a modularized version of Raspberry Pi 4. So people who've been prototyping their next commercial product on Raspberry Pi 4 will have an opportunity to leverage our investments in the platform without having to accept our form factor decisions. And that's always how we think about modules, right? Not forcing. You actually see a lot of products where you look at them, you look at the position of the USB connectors and the Ethernet connector and the HDMI, and you can tell it's a Raspberry Pi, right? But there are always going to be people who don't want to take our form factor with them, and that's what. Yeah. So CM4 is relatively imminent. I mean, I would hope that CM4 will come out towards the end of this year, and that helps move the platform on.
Amazing. Speaking of form factor, the Raspberry Pi Zero, that's been massively popular for you guys, continues to be massively popular. Are there plans for any more spin-offs along those lines?
So Zero has been incredibly popular for us. I mean, it's actually the ventilator product. All of our ventilator wins are actually Zero wins, rather than big product wins. Yeah, I think we're kind of slightly backed into a corner with Zero by the form factor. If you look at Raspberry Pi 1 and Raspberry Pi Zero, they use package-on-package memory. The LPDDR2 memory is stacked on top of the processor itself. That's useful on Raspberry Pi 1, and it's essential on Raspberry Pi 0 because it's the thing that lets us realize the form factor. Now, if you look at Raspberry Pi 2 and Raspberry Pi 3 and 3 Plus and 4, they all have discrete memory. So they have memory in a separate package on the board. And the problem there is that there's no real room to do that in the Zero. Certainly in the single-sided Zero form factor, there's no real room to do that. So we don't have an obvious silicon. We don't have an obvious silicon platform that we can't. You might imagine us walking Zero forwards 1 or 2 generations behind the big product. So moving Zero to the Pi 2 silicon or Pi 3 silicon, but it would require a form factor change. So we're kind of slightly, but it's an enormously popular product, right? And it's enormously important because while we think of $35 as being, $35 we get a cheap computer, $35 is a lot of money. It's a significant amount of money for a lot of people, certainly in this country, let alone elsewhere in the world. And so Zero has always been important to us because it's about us challenging ourselves to not get fat and lazy. Moore's law lets you do 2 things, right? You can either pick a price point and then every year fill it up, or every 2 years fill it up with twice as much performance, or you can take a performance level and you can ride the Moore's law curve down on cost. And really, Raspberry Pi is the result of the big product. Is the result of taking performance points from a couple of years ago and riding the Moore's law curve down. When we launched Raspberry Pi 2, after we've been in the market a few months, we looked around and we thought we've made the same mistake, haven't we? We picked our price point and then we filled it up with performance again. So Raspberry Pi Zero is will always be important to us because it's always an example of us trying to do our signature thing with Moore's law, which is to I guess milk it for cost rather than for performance. I'd love to do a 0203, but there's probably a silicon. Annoyingly, there's probably a silicon program between us and that product, and things that have silicon programs between you and them tend to take half a decade. Raspberry Pi 4 was half a decade in the making.
And again, looking ahead, are there any plans for a USB-C Raspberry Pi aside from for a power source?
Aside from power, no, I don't think so. It's got problems as a connector standard, right? It's got an incredible market image, but in practice, it's not obviously superior to the older connector standards as a host. Unless you're a laptop or a phone and you want to be very thin, then it's, from a physical robustness perspective, it's certainly no better than the legacy connectors. So I don't think you're likely to see that end of the Pi turn into that kind of boat tail that we have on the end of the Pi there. I don't think it's likely that you're going to see that evolve into being an Ethernet connector and 4 USB type Cs anytime soon. It's good for power. I mean, from our point of view, what's good about it from the point of view of power, once you've got your implementation right, is that it's you can push 3 amps through it. So you can get your 15. For us, remember, power for us is mostly about downstream power. It's much more about downstream power than it is about onboard power because we're already consuming about as much power on the board as you can without cooking. But our goal is always how much power have we got left over to pass downstream to USB devices. So that extra half amp, that extra 2.5 watts has been very valuable. Just thinking of this from a kind of a world where, 2.5 amps, which is what we did before, we were already pushing that micro B connector as hard as you really want to. And it's taking us to a world where we're no longer pushing the connector harder than we're no longer pushing the connector to the limit, and you're no longer marginal if you want to plug a heavy power consumption, a single heavy power consumption downstream device. Yeah, it's
amazing.
We always want about 1.2 amps. We always want about 6. Kind of the goal is always to have about 6 watts available, because that will let you power a mouse, a keyboard, and something heavy. The USB-C as a power jack lets us do that very quickly.
Amazing. We've actually just had a really interesting viewer question through, so I'm going to put this one to you, which we don't usually do, but it is really good. So what is the latest news on 64-bit Raspberry Pi OS? Will it be launched soon, and will it make the Pi 4 faster?
Right. Well, there's a beta. So when we, I guess your reader probably knows, there was a beta when we launched the 8 gig product. The same day we did a beta of 64-bit OS. When will it become? I think there's a piece of technical. I mentioned that there's a good thing about the 64-bit world is that we reduce the fraction of the platform that's controlled by the closed source elements of the design. The big change that's got to come in is KMS for display control. So currently in 64-bit, we're still controlling the HDMI peripheral from the video core, from the GPU rather than from the ARM. There's a bunch of patches going upstream at the moment. There's some fantastic support from some of our colleagues in France to get those patches written and upstream. They're going upstream. Once they're in a good state, I think a pretty good state, once they maybe had a little bit more upstream review, we'll switch 64-bit over to that. We'll then beat through the inevitable compatibility. There's nothing more terrifying, I think, than interoperability with, people thought interoperability with power supplies is bad. Interoperability with displays is terrifying because there are vast numbers of displays. So what we do is we switch to KMS, we beat through 95, 98, 99% of the compatibility issues that introduces, and then we should be pretty much ready. We should be pretty much ready to go. End of the year, maybe. It's a bit of a hostage to fortune. It's how long is a piece of string, because we won't really know until that code goes out in the wild and beats people's televisions. Does it make things faster? It makes some operations faster. We've been pleasantly surprised. One thing I was a bit concerned about was I didn't know how stable obviously the legacy ARM instruction set, the AArch32 instruction set from the 1980s. There's been a vast amount of investment in making compilers good at AArch32. I was a bit concerned that compiler maturity for AArch64, the 64-bit instruction set, might not be there, but it does appear to be. So in general, there's a wonderful, I think if you were to Google, there's a chap called Roy Longbottom who's just run a very, very large, very comprehensive set of benchmarks of 64-bit against 32-bit Raspberry Pi OS. It's not a clean sweep for 64-bit, but there are some areas where it's very, very, very compelling. There are some areas where you get 2x performance increase. So I guess what we'll do is we'll go through, find the ones, we'll try and turn it into a clean sweep, as much of a clean sweep as possible. So I think there's probably going to be, it'll be 10 or 20%. But as I say, we've never been an organisation to turn our noses up at 10 or 20%. That's kind of how we define ourselves. So it'll be good. The challenge, of course, for us is backwards compatibility. We're very proud that the 32-bit OS, our 32-bit OS release will run. If you go and download that today, and you have one of the vanishingly rare alpha boards from 2011 that preceded real Raspberry Pi, that image will run on that board. And that's been really important to us. And so there is a little bit of a sense that we could end up doubling our effort if we're not careful. If we don't want to deprioritize 32-bit, but neither do we want to have twice the number of people maintaining the platform. So that's going to be
amazing. And I guess sticking on the software side of things, so we've touched on Netflix, it'd be great to have Netflix up and running, certain video conferencing tools that aren't yet supported. If there was no technical limitations, what's one thing you would love to see running on the Raspberry Pi?
More games, Unreal Engine, Unity and Unreal, Unity actually. I think, so mobile Unity, mobile Unreal Engine. There's no technical reason with the Raspberry Pi 4. Raspberry Pi 4's GPU is comparable in performance to a mid-range smartphone, and there's no reason why all of those titles couldn't run on the Pi. So I'd love to see that. It's kind of interesting, right, that there is no commercial games industry for the Raspberry Pi, and it's slightly surprising because even if you just restrict yourself to the fraction of our customer base who aren't air conditioners, who aren't running a factory on our product, who actually have it in front of their television, that's still millions and millions and millions and millions of people. It's really quite substantial installed by games console standards. It's not a PlayStation 2, but by games console standards, it's actually not a bad install base. And it's always been a little bit of a surprise to me there isn't the commercial games, that there isn't really any commercial software, and there's certainly no commercial games industry. And a lot of that is about tooling. A lot of that is about whether your runtime supported. So I'd love to see some game runtimes on there, and I'd love to see. There's lots of games I like to play that I'd love to see on the platform.
Yeah, that'd be awesome. I don't know how this has happened, but we have time for one more question. So I am going to ask, what is your favourite project you've seen?
Not counting our own, because there's no kick like having the conversations I did in the corridor at the office a few days ago with someone saying, "Oh, we need to do X for our space program." So there's no kick like that. In terms of other people's, I mentioned it a lot. The cucumber sorter is a lot of fun. There's a Japanese cucumber sorter, an engineer in Japan whose parents run a cucumber farm and who trained up a TensorFlow. They need to sort their cucumbers into 30 different varieties based on how green they are and how long they are and how knobbly they are. And he built his parents are getting a little bit older, didn't like spending their days doing this, and so he built a TensorFlow model, trained a TensorFlow model to recognize the different grades of cucumbers, built a little robotic machine with a conveyor belts and little flippers to flip the cucumbers into bins, and saved his parents a whole heap of work. It sounds sounds a bit fatuous. It sounds a bit frivolous, but it's actually quite a nice little toy example of what people do with Raspberry Pi. Raspberry Pi is a piece of glue for sticking other things together in order to solve a problem you've got. So this was him sticking together camera and local processing and remote processing and actuators affecting the physical world and solving a problem that he had. And almost everything, roughly half of Raspberry Pis were sold, 6 and a bit million Raspberry Pis last year. Roughly half of those, a little over half of those, we think, went into industrial applications. And to a very great degree, those are all examples of that. They're all examples of some engineer. Often these things are sold up within organizations. It'll be an engineer on the front line who's got a problem to solve. He looks around for what tools he's got in his toolbox. The Raspberry Pi is often the thing they end up using, and then they sell it up. They build a prototype, and they sell it up inside the organization. And that's why I like the cucumber sorter. And I like cucumbers as well. So that's good kind of personal resonance as well.
Amazing. I'm afraid that's all we've got time for. I'm going to go look up this cucumber sorter now. It sounds fascinating. Thank you so much for joining us, and we hope you'll join us for our next session at 3:30, where we'll be looking at balancing the theory of innovation with business reality. Thank you.